Alright, here's page 3 of the Algebra 2 Fall Final Review. Looks like we have some inequalities to solve and some absolute values inequalities to solve here in 15, 16, and 17, 18. This first compound inequality, so 3 is less than 2x plus 3, which is less than or equal to 7. Essentially, we want to kind of split this problem up into two problems and then just solve each part. So we get 3 is less than 2x plus 3. And then the other part being 2x plus 3 is less than or equal to 7. And we're just going to solve each part of this. Essentially like it's an equation, so subtracting 3 from both sides here gives me 0 is less than 2x, and dividing both sides by 2. So 0 is less than x. And similar idea over here, so minus 3 minus 3. So 2x is less than or equal to 4. Divide by 2, divide by 2. So x is less than or equal to 2. I'm just going to take those two pieces and put them back together to one answer. So that'd be 0 is less than x, which is less than or equal to 2. Is our final answer. So somewhere between 2 and 0 is where x is. The next problem is essentially just two problems kind of pushed together in one. So 5x is less than 15, less than or equal to 15, or x plus 6 is greater than 13. So I'm just going to solve each one kind of individually. So on the first one, I'm just going to divide by 5 first. And so here we get x is less than or equal to 3. And the second one, x plus 6, so subtract 6. So x is greater than 7. So x can't be less than 3 and greater than 7. So we just put that or back in between them. And we are done. So those are pretty simple. Absolute value inequalities. We just did absolute value problems on page 2. So that similarity between that we want the absolute value piece to be isolated before we try to solve that. So in this particular problem, it's isolated. There's nothing to get rid of on the outside of that. The other thing we did with that is that we split that problem into two problems before we solved it, and solve each part. So as I rewrite this, it becomes x plus 2 is greater than 9. So that part pretty much the same. The bars are gone though, and then the other part would be x plus 2. So that part inside the bars stays put, but then instead of being 9, we have negative 9. And as we make that a negative, we also remember to flip the inequality symbol around. So there's two things we have to change there. And then solving these two equations is pretty simple. So subtract 2, subtract 2. So x is greater than 7. Here we subtract 2, subtract 2. So here we have x is less than negative 11. So at this point you should stop and ask yourself, like, is this an and problem or an or problem? One of the ways we did this in class was to draw it out. Just a quick sketch. So I have negative 11 and 7. It says x is greater than 7, which means it would be opening to the right, and then x is less than negative 11, which means it would be going to the left. So this isn't or, since they go away from each other. And so what that means, all I have to do is write x is greater than 7, or x is less than negative 11. And so there's our answer there. So you can use the visual, or you can just ask yourself, can a number be bigger than 7 and less than negative 11? No, a number can't do that, so it's have to be an or since it can't be an and. Pretty similar problem over here with 18. What we're going to do is split this problem in half first. So one part being x over 2 plus 6 is less than or equal to 10. The other part being x over, oops, pen's being weird here, x over 2 plus 6 Now switch the symbol around so it's greater than or equal to, and then flip the sign, -10. So I'm just going to solve each part. So I'm going to subtract 6. Say x over 2 equals, or not equals, it's a really common mistake. It's less than or equal to 4. And multiply both sides by 2. So that means x is less than or equal to 8. And over here, subtract 6, subtract 6. So x over 2 is greater than or equal to -16 times 2 times 2. So x is greater than or equal to -32. So if you want to use a number line here again to help you figure out if this is an AND or an OR problem, so I'm just going to draw a quick number line. -32 over here on the left, 8 over here on the right. Says that x is less than 8. Less than or equal to, which means for closed circle, it doesn't really matter, it's the arrow that really matters here. And x is greater than or equal to -32, which means a closed circle again. So those are going towards each other, which means this is an AND problem. And since this is an AND problem, we want to put it in order. So -32 to go with the left since it's the smallest. So -32 is less than or equal to x. So here this says that x is greater than or equal to -32. It's the same thing as saying -32 is less than x. And then x is also less than or equal to 8. So then bringing that side down. So that's what your answer should look like for that. So because it's an AND, we do need to rewrite it in the proper compound inequality notation. All right, so there are those problems. Looks like we're moving into some factoring next. Let's talk about just things we should be thinking about before we start the factoring. So let's just talk about what our methods of factoring are. And there is a typo here on number 26 that you want to fix. That less symbol should be a plus sign. So make sure you fix that on number 26. But things I want to think about, what the types of factoring we learned. So you guys have that factoring graphic organizer, which really can be helpful for you to make sure you're remembering your factoring. But the first type of factoring, the most basic type of factoring we have is GCF factoring. So what do the terms have in common? Always look for that. From there we said, well, what if there's two terms? That would be like a difference of squares. Pretty common type of factoring we saw. And then there was also sums and difference of cubes. That was the CC-SOPs method. And then those two terms. And then for 3 terms was our AC method. And 4 terms was grouping. So I'm looking at this first problem, number 19, seeing it has 3 terms. Also noticing that each term does not have anything in common, so I'm not going to be able to do GCF. Just going to go straight into the AC method. So my A times C, so 1 times 6 is 6, and I'm going to take that to give me 5. So remember the factors of 6 that add to be 5. So 1 and 6, and then 2 and 3. So x squared plus 2x plus 3x plus 6. 4 terms now, so we split it. Both have an x in them, so that's x plus 2. Here these both have a 3 in them, so make sure you write plus 3 there, not just 3. And these with x plus 2. X plus 2's come together, and then the x plus 3 leftovers come together. So there's my factoring there, AC method. See on number 20, I'm seeing 2 terms. 8 and 343 don't have anything in common. I noticed that there's a cube there with the subtraction. This is a difference of cubes. This is going to be a CC-SOPs problem. So you guys have a list of perfect cubes on one of your worksheets. You might want to find that. If I know that the cube root of 8x cubed would be 2x, so that's my C. Then follow the sign here, that minus sign comes down. The cube root of 343 is 7. So there's my other c, so there's my cc. So then I stop paying attention to the original problem. I go, just look at that binomial that I just wrote, and this is where my SOPs comes in. So the first s is square, so I take that 2x and I'm going to square it. O stood for opposite sign, so that's a plus sign now. And then P stood for product, so I'm taking the 2x times the 7. Don't worry about the minus sign, it's just the 7 we need. That last sign was always a plus. And then the last s stood for square, so that's going to be the 7 squared. So what that gives me is 2x minus 7. 2x times 2x is 4x squared, plus 2x times 7 is 14x, and then 7 times 7 is 49. So there's my factorization of 8x cubed minus 343. Alright, here is number 21, which is 2x squared plus x minus 15. There's no GCF, there are 3 terms, so look at AC method. My A times my C would be negative 30, so 2 times negative 15, negative 30. I need negative 30 to give me 1, which is my B value. So factors of negative 30 to add to be 1. That would be like negative 6, or no, positive 6 and negative 5. And remember, it doesn't matter what order you put them in here in the middle, but I'm just going to go ahead and put them in the order I wrote them. So 2x squared plus 6x minus 5x minus 15. Now I have 4 terms, I'm going to break it. 2x squared and 6x both have a 2x in them. Leaves me with an x plus a 3. Negative 5x and negative 15 both have a negative 5 in them, so I take out that negative 5, leaves me with positive x, positive 3. And so those x plus 3's go together. And the 2x minus 5, the leftovers, go together. So there's my factorization for number 21. AC method. Going over to 22. Also 3 terms, don't see any GCF among them, so that's going to be another AC method problem. My A times my C, 4 times negative 3 would be negative 12. I need that to give me negative 1, which is my B value. So factors from negative 12 that add to be negative 1, which would be negative 4 and positive 3. So 4x squared minus 4x plus 3x minus 3. Break it. Those both have a 4x in them. Leaves me with an x and then a minus 1, not a 0, but a minus 1. And these next 2 terms both have a positive 3. Again, put a plus 3 there, not just a 3. And then leaves me with an x and a minus 1. X minus 1's go together. And the 4x plus 3 goes together. There's my factorization for number 22. 23. Let's see, 2 terms. I do not have a GCF. I have a square here, not a cube, so this is not a difference or sum of cubes, but it's a difference of squares. So I have 2 terms, subtraction, and both of these things are perfect squares. So this is one of the easiest types of factoring, I think. We have the 2 sets of parentheses. There's always that one that has a plus in it and the one that has a minus in it. I always just ask myself, where does 9x squared come from? That's 3x times 3x. So that goes in the beginning. And where does 16 come from? That's 4 and 4, and so that goes in the end. And then, boom, done. Number 24, let's see, kind of looks like a difference of squares like the one we just did, except for 5 is not a perfect square. And the other thing I noticed is that this does have a GCF. So there is something in common between those 2 terms. So that's a 5, so I can take that out first, which leaves me with x squared minus 4. And then now looking inside those parentheses, I'm seeing that now that's a difference of squares, because the y squared and then the 4 is also a perfect square. So that y is going to come down in the front, because y times y is y squared. I got a plus and a minus, and then 4 comes from 2 and 2. Now, the only thing I didn't do was bring down that GCF I took out earlier, and that'd be really bad if I didn't do that. So it's be 5 times y plus 2, y minus 2. And there's my factorization for number 24. Not too bad. Like those differences of squares problems, they're fast. 24. Let's see. We've got 3 terms. Looks like I got a lot of stuff in common though. So let's see what we can take out. Let's see. As far as numbers go, 3, 2, and 1 don't have anything in common like as far as the coefficients go. But I do have some A's. Let's see, this one has 2 A's. This one has 1 A. This one has 3 A's. So that means I can at least take out an A out of everything. Just 1 A I can take out of everything. So I'm bringing A out. And then this one has 1 B, this one has 2 B's, this one has 3 B's. So again, I can only take out 1 B since most of the first term has to give up is 1 B. So take out AB out of everything. So I take AB out of there, it's going to be with the 3, 1A will be left over, and that B is going to cancel. Move on to the second term, that's plus, so the 2 will stay, that A will go away, and B times B would be B squared, so I need a B. Then move on to the third term. So I've got 1A here, I need 3, that means I need 2 more A's. I've got 1B here, I need 3, and it means I need 2 more B's also. So I should look back inside the parentheses, make sure nothing's still in common. This one has a 3 and an A, this one doesn't have any A's or 3, so there's nothing in common there. And that shouldn't be factorable with like AC method or anything like that. So this would be just some GCF factoring for number 24. So then to 25, we got 3 terms, but it looks like we definitely have something in common first. Noticing I see 2's and everything, I also see a y and everything, so first thing I'm going to do is take out a 2y and see what's left over. So I'll leave me with a y squared, and minus, so the 2's will cancel, and then one of those y's will cancel, leave me with 1 more y, and then 6 divided by 2 would be 3, and no, the minus 3, and the y's will cancel. So I get 2y times y squared minus y minus 3, so I'm guessing this stuff inside the parentheses here will still be factorable using the AC method. So I've got AC 1 times negative 3b, negative 3. And I need negative 3 to give me negative 1. And the only factors of negative 3 are 1 and 3, and there's no way to arrange those to give me negative 1 as a factor, or as a sum. So this must not be factorable using the AC method. So that means we're done initially. Alright, last factoring problem. So yeah, 4 terms. As I glance through looking for GCFs among everything, they do not all share anything, so can't do any GCF, but I have 4 terms, which means I should be thinking about grouping. So my first 2 both have x squared in them, x and minus 5. The next 2 both have a 9 in them, so it's going to be negative 9. And then you have the x and then a negative 5. Make sure you switch that sign up there. And then the x minus 5 will come together. And then the x squared minus 9 will come together. So what I'm seeing, so x minus 5 is not going anywhere, but this x squared minus 9 probably still factorable since I see that square there, so just check that out. And I notice that's 2 terms, got a square. Both terms are perfect squares, so this is a difference of squares. So I have 2 sets of parentheses. One's going to be a plus, one's going to be a minus. X comes from x and x. X squared comes from x and x, and then 9 comes from 3 and 3. And then do not forget to bring that x minus 5 down. And there is our completely factored answer now. Alright, there was page 3.